Hi everyone, in today's video we are going to use rename, select and mutate function, and we will be applying simple linear regression, multiple linear regression, and we will also discuss some assumptions of linear regression including multicollinearity as well, and then we will plot actual versus predicted lines or predicted values in RStudio. So let's open your RStudio. So let me close this one. Okay, so let's open your RStudio. Again, I believe now you know how to open RStudio, how to set working directories. If you don't know, please go to my previous video. So there is a step-by-step guide are available over there, how you can set the working directories, how you can open the files. All right, so for today's video, you need these two packages to download. So if you have not installed these packages, please install these packages and load these libraries. If you do not know how to install packages, again, install packages is the command, and then in the inverted commas, dplyr. Because I have already installed these one, so that's why I'm not installing it again. The other one is tidylog. These two packages are extremely useful for data wrangling. All right, so you can hit Control Enter to load this, install this package, and then again Control Enter to install this package. Again, once you install these packages, you do not need to install these packages again and again on your machine. So I am just removing it. Okay. So just run Control Enter, Control Enter. So I have installed these two packages and loaded these two packages. So now I'm gonna call some data. So RStudio have some built-in data that calls empty cars. So if you write just data in the inverted commas empty cars and run Control Enter, the data will be uploaded automatically over here on your environment window. So to look at the data, just click on this one and see the data tab is now open. So miles per gallon, CYL, disp, HP, TRAT, WT, QSAC, VS, AM, gear, and crab are the name of the variables. If you are not sure what are the meaning of these variables, what 1 stands for, what 0 stands for, if you are not sure, just go to your console, write question mark and say empty cars. Hit enter. And on your fourth window at your right hand corner, so you can see the explanation of this data. So here is the explanation of these variables: miles per gallon, cylinder, number of cylinder, disp is displacement, VS is engine, AM is transmission, gear is number of forward gears, and crab is number of carburetors. All right, so I'm only interested in few variables just for the exercise. You can select or remove, drop variables by your own interest. How to select or drop variables, you can watch my previous videos. All right, so let's name the data whatever you want to. I want to name the data like CS_data, cross-sectional data, because in the future videos I will be talking about the time series data as well. So over here I just want to name this data as CS data. All right, so I name this data as CS data, then use select function. Select is used to select the variables from. This is the data I want to select from, this empty cars data, and these are the name of the variables I want to select. Only these 1, 2, 3, 4, 5, 6 variables. So let's run this command by hitting Control Enter. So now see, CS data is over there in my environment window with 6 variables. It's always a good practice to see your data first. So just like str, structure of the data, str command shows the structure of the data. So now you can see the structure of the data. Miles per gallon is numerical variable. cylinder is numerical variable, HP is numerical variable, WT is numerical variable, AM is numerical variable, and gear is also numerical variables. If you want to see some few observations of your data, you can use this command head and then write the name of the data, CS data, and hit Control Enter. See, now the first six observations are there: miles per gallon, cylinder, HP, WT, AM, and gear. All right. If you want to see some more observations, you can also put comma and then write 10. So in this way, you will be able to see the first 10 rows. See, now you are able to see the first 10 rows in your console window. Okay, the AM variable actually is making confusion for me. So MPG, I can understand it's miles per gallon. CYL, I can understand it's cylinder. For HP, I can understand its horsepower. WT, I can understand its weight. But AM, it's a little bit confusion for me. It's not. It may be not confusion for you, but it's a little bit confusing me. I want to just change the name of AM to transmission, or in short, trans. So how I can do that? So I can write the CS data, again the same data I want to save in. If you write the different name of the data, then a new data will be created. I don't want to create a new name. I don't want to create a new data. I want to use the same data but with a different name. So first, let's have a look on your data by simply clicking on this one, and see CS data is now open. MPG, CYL, HP, WT, AM, and gears are there. Okay, so go back to your RFC file or script file, and now change the name of the variable by using CS data, rename. CS data trans is the new variable name that you want to keep, and AM is the old variable name. So just run this command. Yeah, so see, renamed. If you want to see it again, click here again. Now you can see trans is there. Now, if you're not sure what is 1 and what is 0, it may be a little bit confusion for you. So I just want to change 1 and 0 to automatic and manual, but I don't know which one is auto and which one is manual. So again, I have to go back to the empty cars data on my right hand down corner window. So over here I can see AM transmission, 0 means automatic and 1 means manual. Okay, so I can see that 0 is automatic and 1 is manual. How I can change these values? By using recode function in mutate. So this is the name of the data I want to save in, and then mutate CS data. Trans is the name of the variable I want to create, and I don't want to create a new variable. I want to create a same variable. So that's why I have kept the name exactly the same of my previous variable, just like the previous variables. For example, this is the trans variable name. If I want to create a new variable, I have to change the name of this variable. I can use trans1, then a new variable will be created. If I don't want to create a new variable, then I have to keep the name of the variable exactly the same, like this, trans. So I'm keeping the name of the variable same, trans, and then G code. I wanna recode this trans variable, trans 0 into auto and 1 into manual. Don't forget to put comma over here, and then in the inverted commas these auto and manuals. Just run this command by hitting Control Enter. Yeah, so now see, you are getting a message down there in your console window that the mutate converted trans from double to character 0 new NA. 0 new NA means no missing value is generated. So just have a look on this one. See, so now trans, manual, auto, manual, auto. One more thing you should notice that there are some variables which are factor variable or categorical variable, and some variables are numeric variables. But remember previously when we checked the structure of the data, So we have almost all the variables in numeric. See in your console window. So over here, MPG was numeric, cylinder was numeric, HP was numeric, WT was numeric, but we know that this trans is not a numeric variable. It is a factor variable or a categorical variable. I also know that CYL is not a numeric variable. It's a categorical variable. And gear is also not a numerical variable. It's a categorical variable. It has categories. Why it's called, this is why it is called a categorical variable or a factor variables. So how we can check the class of this variables again, the structure with the structure command. So now, if you want to see what is in that variable, so simply write table command, like in the previous video I have told you table, and then cs data, call the variables by putting $sign, and when I see the cylinder, see it only says 4, 6 and 8 cylinder cards are there. All right, you can also see trans. There are 19 auto cards and 13 manual cards. You can also check with gear. There is 3 gears cards, 4 gears cards and 5 gears cards. 3 gears cards are 15, 4 gears cards are 12, 5 gears cards are 5. Okay, so now we know that these are factor variable. So we should first of all change the structure or the class of the variables. How you can change the class of the variables from numeric to a factor variable? The command is as.factor. All right, so just write the name of the variable like cs data $trans, and then assign it to as factor cs data $trans. And similarly with cylinder, similarly with gear. So now these variables are created into factor variables. Now let's start to apply the simple linear regression. Linear regression. Why it is called simple linear regression? When we are checking one variable with another variable, the relationship between two numeric variables, then we are going to work on simple linear regression. It's also called the OLS, ordinary least square method. Why it is called ordinary least square method? What is simple linear regression? I'm not going into too detail in this video because it's too much econometric topic, and I have to make another video on simple linear regression. Otherwise, the time would not allow me to do so in this video. Okay, but you must understand that when we are applying simple linear or multiple linear regression, we are trying to look the linear regression, the linear relationship between the variables. If it is a simple linear regression, it means I'm going to use the only two variables. One would be the dependent variable and the one would be my independent variable. All right, so again, a linear regression, a linear relationship. All right, for example, I have miles per gallon in a numerical variable. My miles per gallon is a numerical variable, and HP is also numerical variables. I'm gonna see the relationship between miles per gallon and horsepower. So SREG is the name of the model you want to save in your results, and then assign it. LM is the name of the command, linear regression, linear modeling. So you can use LM, then CS underscore data $miles per gallon, and then tilde CS data horsepower. This is your dependent variable miles per gallon, and then CS underscore data horsepower is your independent variable. So just run this command. See, in your console window, this is generated. So you want to see the summary of this one, you have to go to write the summary and then s_reg. So now this simple linear regression actually gives you estimates, coefficients. So in this video, in this regression, simple linear regression, so you will get the two regression coefficients. One is for intercept, the other one is for your variable. So this one is minus 0.068 is highly important, and this is what it shows. Actually, I'm going to just interpret these results. It says with the increase of 1 horsepower, your miles per gallon will be decreased by 0.068 units. Okay, so this is the interpretation of this coefficient. Standard errors with these errors, with the error, it's always trying to minimize your errors. So if you have lower errors, it means your prediction is nearly accurate or accurate. T-value is t-value, and you must also be interested in looking at these p-values. P-value, if it's less than 0.05, it means your results are significant at 95% confidence interval. Okay, so these 3 stars shows it. These results are significant even at 99% confidence interval. Okay, so if you have 1 star, then it means it's a significant at 90%. 2 stars mean significant at 0.0, significant at 95% level. Sorry, I think so. It shows like here. So significant is 3 stars means it's a 99.99, and then these 2 stars mean 99%, and 1 star means 95%, and dot means, actually when you get the dot, then it means it's a significant at 90%. Okay, so if 3 stars I am getting, it means 99.99999%. The results are highly significant. Okay, so this was the interpretation of simple linear model. So you can you can run another model. So like I want to check the relationship between MPG and weight, but see that I have written this command differently than the above one. So I have directly used the name of the variables like MPG tilde WT and then comma data CS data. This is the way you can also use this command. So instead of mentioning the data over here, you can also run the command like this: miles per gallon tilde WT and then comma. You have to specify which data you want to use. So I'm going to run this command again. Yeah, so because I haven't changed the name of the file, so that's why it's just replaced the old file. And now check the summary again. See, now I got the intercept and WT. So you must understand what is the value of intercept, what is the meaning of intercept. All right, so intercept means even if you don't include your independent variables, this explains the miles per gallon in the absence of your independent variables. If you include the independent variables, then this will be intercept will also be changed. So if you are not sure, so I just have changed the variable from HP to WT, the intercept would also be changed. See, in the previous one it was 30, and over here it is 37. Okay, so now the things we are interested in is the coefficient of, or the estimate of WT variable. It says minus 5.3445. It says, it means I'm gonna again interpret this my results. It says with the 1 unit increase of weight, miles per gallon will be reduced by 5.3445 units. Negative signs means it has an inverse relationship, and again 3 stars means it is highly significant at 99.99 confidence interval. All right, now we also want to include some more variables. It's highly unlikely in our practical life that we have only one dependent variable and only one independent variable. It's possible that the miles per gallon also depends upon horsepower, weight, transmission. Okay, it's also possible that in your case, in whatever you are doing your research, your dependent variable also depends upon more than one variable, and that more than one variable could be numeric and categorical. So that's why we have to first figure out, we have to first settle down, make sure that what variables we have in vectors and what variables we have in numeric. So in multiple linear regression, MREG, so I just want to make a comment over here. This is called regression. Okay. From here, it's multiple linear regression is started. Okay, so MREG is the name of the file. I want to save my results, and then LM again linear, it shows linear, and then MPG tilde HP plus WT plus trans and comma data CS data. So I have included 3 independent variables now. 2 of them are numeric and 1 of them is vector variable. So let's run this command. Again, I can see over here. So let's see the summary. Again, the command to see the summary of the result is again summary in the bracket MREG. I can see over here HP, WT and trans manual are given over here. What it says HP again has a negative relationship. With the increase of 1 unit increase in horsepower, miles per gallon will be reduced by 0.03 units. All right, and with the increase in 1 unit of weight, miles per gallon will be reduced by 2.878575 units. Interestingly, you should see over here, it says that the manual cars, so when we have 2 categories in manual, in transmissions, manual and auto. So this coefficient represents the effect of manual cars as compared to auto cars. So because we have 2 categories in our independent variable transmission. So I'm going to interpret these results. Please be attentive. So it says that as compared to the auto cars, manual cars have 2.0837 more mileage. Again, as compared to the auto cars, manual cars have higher mileage. How much? By 2.083 units. But this shows the results are insignificant. All right. That's a separate matter, but you should understand how we can interpret the results of a categorical variable. So let's include another categorical variables like cylinder. So in our next command, I am including another categorical variable, which is cylinder. Transmission and cylinder, they are 2 categorical variables and 2 numerical variables. So let's run this command again. MREG. So it has replaced the old file MREG, and let's see the summary of MREG now. See, these are the results. Horsepower, again, I have just explained this, it will be similar. So now it says manual cars have 1.80 more mileage than auto cars. Similarly, see, it says CYL6, CYL8. It means Cylinder 4 is our reference category. So we're going to compare these 6 and 8 with our reference category. So I'm going to interpret these results. For cylinder 6, it says as compared to cylinder 4, as compared to cylinder 4 cars, the cars who have which have 6 cylinder cars, they have 3.031 less mileage as compared to 4 cylinder cars. Okay, and similarly 8 cylinder cars have 2.16 less mileage as compared to 4 cylinder cars. Remember to compare your estimates, your coefficients with your reference category. All right. Again, so this is how you can apply your simple linear and multiple linear regressions, but there are important things are coming up. If you just copy these results and want to take out in your Excel, so let's try. How can I take it? It will be a little messy. Okay, so if you know how you can convert these to data, that's fine, that's excellent. If you can, if you don't know, then it will be a little messy. You will be unable to unable to have a little bit, nice tidy results. So for that one, there is a package called Broom. So again, you have to install this package first. All packages, then Broom, because I have already installed these packages, so that's why I'm not installing it again. You can install these packages Broom and then load it with a library. So first, I think Stargazer you can ignore it at this stage. So we will talk about Stargazer at the next point. All right, so run this one, install the packages and then library Broom, and then I want to save my results by using this command. Okay, so results sreg and then tidy sreg. Tidy is the command for tidy up the results. Sreg, it means simple linear regression. I want to use this one, sreg, and see result sreg is generated. So you need to click here, and from here you can copy. Can take your results to your Excel file. Just copy this one, cut it the above line and then paste it over here. Here we go. So now you have nice looking results. So just change it to your number and then three decimals are fine, and that's it. And then you can play with it. You can change the look of the table as you like. All right, and you can do it with the similarly with mreg. Right. Okay. So for example, let's say if you want to see the coefficient of, so first let's try to bring out the multiple linear regression results as well. So I'm going to run this command. I just have run this command, tidy mreg, and if I look on my environment window, result mreg is generated. I will click on this one, copy this one, select and copy, and then take over here, copy this one, just cut it and paste over here, and this one again, double click, it will open up like this, set to a 3 or 2 or 3 is better, I think so. Set to the 3, and then so I'm just I'm just trying to make my results a little bit beautiful. And then I can also show you like this. See, like this. So these are the results. You can copy these results and go to your Word file, and then you can copy it like this. All right, and whatever you want to write the note, and you can write the note down there. Okay, and also change the name of the variables, like complete variables, let's say horsepower, something like that. Okay, you can change the name of the variable. Okay, back to our discussion. It's possible that you wanna see the coefficient of auto rather than transmission manual. You wanna see the coefficient of auto. So what will you do? You wanna change the level of the reference category of this variable. So here it says this reference category is auto, and the coefficient is a manual coefficient. But you want to see the coefficient of auto and make this manual category as your reference category. Okay, so how you can do that? So this is the command to change the reference category. Relevel is the command for changing the reference category. So you will write the name of the variables, CS data $trans, and then relevel CS data trans, comma, reference is your now manual. Okay, so you want to change a reference category from auto to manual. Just run this command. So, and you need to rerun this your regression, multiple regression. For example, this one mreg. So I'm going to rerun this command and see the summary again. See, now I got auto. So it's almost similar but in opposite direction. So now it says auto cars have less mileage, 1.80 mileage is less than the manual cars. Again, remember to compare it with your reference category. Okay, how you can apply simple linear and multiple linear regression and take your results out for nice presentation in a Word file. Okay, so now you can check your assumptions of the OLS. If you're not sure about the assumption of OLS, please consult your econometrics teacher or go through the OLS. In theory, you should understand what is linearity, homoscedasticity, independence, normality, or multicollinearity. I'm just going to explain it here very shortly in just a few words. Linearity, as I said earlier, the relationship between x and y, x and the mean of y is linear. Again, linear. Okay, so this is the assumption of the first assumption. So the relationship would be linear between x and y, are dependent and independent variable. Homoscedasticity, the variance of residual is the same of the value of x. Okay, so remember that we always have some residuals. It means that our residuals are, the variance of residual is the same or the constant. And then the independence means the observations are independent of each other, whatever you are including in your model. And then normality means for any fixed value of x, y is normally distributed. What is a normally distributed? Remember a bell-shaped curve. So it means that it is your y is normally distributed. Multicollinearity means your independent variables should not be overlapped. Okay, your independent variables should not be overlapped, and you should not have multicollinearity, or you have a very little multicollinearity in your model. So you can check it, but just running this plot mreg command is a graphical representation. So if you run plot reg command, so it means, so look in your console window, it says hit return to see next plot. So you're gonna click over here and hit enter. So that's a distribution of your residuals. So over here I can see it's normally distributed. It's fine. It should be a line between these residuals. Okay, it says the distribution of your residual is fine, is normal, and then hit again enter. So it's creating standardized residuals. It's again a little bit fine, and it should be diagonal to diagonal. These are fine, and probably these 17, 18, and 20 are a little bit out of the box, but it still is fine. Run again, and these are standardized residual, the underscore of standardized residuals, scale location, and it's looking again accurate. And then hit enter again, and now they have plotted all the things at once. These corners are a bit out of the box. It shows a little bit out of the box, but still, I think these this regression met your assumptions. But only one thing is missing over here, which is called multicollinearity. Remember if your independent are overlapping or not. To check the multicollinearity, you need to use this package far away. That's a very simple package and very simple one command. You can check your multicollinearity. Again, you have to install this package if you are using first time this package. Far away. Okay, so install this package, run the library, and only you're gonna run this command is VIF, and then in the bracket, remember these are the results you have saved, mreg, these things. You need to put your output name over here, VIF underscore mreg. What is VIF? It says the variance inflation factor. If variance inflation factor of any variable is greater than 10, it means high multicollinearity is present there. If it is less than 10, you do not need to worry. If it is less than 5, it means low multicollinearity. If it is between 5 to 10, it means there is a multicollinearity, but you can still accept it. But if it is more than 10, it means there is a high multicollinearity. And then there are things, there are ways that how you can deal with multicollinearity. That's again a separate topic and needs a separate video. Okay, so I'm gonna just check the multicollinearity as well. So just write VIF and then in the bracket the name of the output. See, HP says 4 point something, 4 point something, WT 4 point something, transmission says 4.2 point something, cylinder 1.8, cylinder 18, 7 point something. So it's all, they're all less than 10. It means your model is still suitable, and the assumptions of your model still met. Okay, one really important thing is that how you can compare now the actual versus prediction values. So what is actual and what is prediction means? So if we go to our data like CS data, so CS data says it has some mileage with these variables. It will have this mileage. For example, if a car is 6-cylinder, horsepower is 110, 2.6 is car speed, and it's a manual and have 4 gears, it will have a mileage per gallon 21. If a car is 4-cylinder, I'm not talking about the third car, and horsepower 93, and weight this, and transmission this, and gears this, it's gonna have a mileage per gallon 22.8. So it means these mileage per gallons are actual mileage per gallons with your given data. One of the main reason of applying multiple linear regression or OLS method is to predict the miles per gallon, or to predict your dependent variable with these variable, with your given independent variable. So for example, I have these 4 independent variables. Let me go back to my mreg command. I have these 4 independent variables like horsepower, WT, transmission, and cylinder. Now I want to predict if these variables are repeating again, what will be the value of miles per gallon? Okay, so this is called my prediction. So I want to predict based on this outcome, based in of this outcome, I'm going to predict my future values. So for this one is the command is predict. So let me go over there again. Here we go. So pred is the name of the file or name of the model I want to save my results in. Pred is equal to predict is the name of the command predict, and then mreg is over here. You are going to bring your mreg over here. That's the prediction you want to make on. So you want to make the prediction on this file and using this data, CS data. So if you use this one, it will create a new factor variable over here, predict pred. Okay, so it says name numerical variables and it goes from 1 to 32. Okay, now I want to plot my miles per gallon first to see how it look like. So for example, so you know that how I can just change the label of X and Y labels. I'm going to explain this command in a minute. So first let me run this command. So if you run this command, so you will get this nice graph on your lower hand corner. So what it shows actually? It shows that it's actually on x-axis, the actual versus predicted is actually not, it's only the miles per gallon. So but I have written it for the future use. It's only the miles per gallon, the actual miles per gallon over from 0 to 30. So this says the miles per gallon, how it is behaving. Okay. All right. So now what I want to plot the predicted value on this as well. So predicted value is this one, pred. So how I can do that? So okay, so let me explain this one, the first command of this one. The plot is the command to plot the miles per gallon. Then CS data $mpg is the original miles per gallon variable, and then type L means lines, then line LWD is width of the line. 2, you can change it. Color is orange, comma. XLab is actual versus predicted down there, and then YLab is miles per gallon. I want to make the label of Y like miles per gallon. Okay, so now I want to make another line on this graph. For this one, I am going to use the predicted miles per gallon. This is the command for this one, lines. Pred is the name of the file that you have created earlier, like this one, pred. Then again type LWD2 and color blue, LWD line width, color blue. So just run this command and see what happens. See, so it goes, so I'm gonna just make it a little bit bigger. All right, so it goes hand to hand and it's a nice prediction. So your model is really good. So it says your model is near to the actual values. Okay, so now the actual versus predicted is there, and then miles per gallon. You can also apply some legends over here. Legends means if you wanna explain what is blue line, what is orange line. So you can apply a legend command, legend in the top left. If you wanna put your legend in this corner, top left, and then see actual miles per gallon and then predicted miles per gallon, and fill it with two color, orange and blue. Remember, this orange color must be the same like the miles, this color, the miles per gallon colors, and this blue color should be the same of this predicted color. Okay, so actual miles per gallon will be will be colored as orange and predicted miles per gallon will be colored as blue, and this is what we have said in our above commands. So let's run this command, legend. So this is how you can get the legend on your top left hand corner. Okay, so you can play with some other things like there is another data, gap-minded data. You can also play with it, gap-minded data, or you can play with your own data. So this is how you can make a nice graph. So how to save this one? So first, if you want to look into detail, just click on the zoom and it will open up a relatively clear. See, actual versus predicted, and you can save this one by clicking export, save as image, and that's the name of the file. I want to say actual versus predicted. It will save in your directory. So you see, I have set the working directory. If you are not sure how to set the working directory, please watch my earlier videos. You will be clear that how we can set the working directories. All right, so let's save this one. It's saved over there. So if, for example, if I want to see where is this graph, see, this is here, R class folder, and I can see a graph over here. It's going to take a little time in opening. And still not, yes, now it's open. Okay, so if you want to keep copy this command, if you want to paste it on in your Word file, just copy it, go to your Word file and paste it over here, and that's it. So this is how you can use all these commands for prediction, for using multilinear, simple linear regression, multiple linear regression. I hope this is helpful. This video is helpful for you. Thank you very much for watching this video.